Reached our last subject of the semester for the last week of the semester, and this is going to be dealing with the subject shown here in your notes too, called registers and counters. This subject matter is also presented in the quizzes, which you have done 9 quizzes, and this is the 10th one, called Important Sequential Logic Circuits, namely registers and counters. So let's take a look at what we're going to cover today. We're going to be looking at the shift register example, such as problems 2 as well as number 7 further down. And we're also going to look at question number 3, which is probably the most difficult question from quiz number 10. Okay, so with that, let's take a look at the notes and let's see where we're going. So what we're doing here is we've got the 5-step procedure done earlier, and so now what kind of things have people designed with their logic design expertise? Well, registers and counters. A register is basically defined to be a sequential logic circuit which deals with the storage and transfer of multi-bit data like 8 bits, 16 bits, 32 bits. So the size of the registers can be 32 bits or 64 bits, etc. Now, the data can be moving in and out of the registers, and we have some mnemonics here we call parallel in, parallel out, PIPO. We're also going to demonstrate some of these other ones, SISO, PISO, SIPO. So let's go ahead and dig into this. Our first example called the data latch register, and you're going to have to know by basically 4 or 5 of these as shown in, if I can go back here, question number 1 here. I will put up one of 4 or 5 different circuits here, and this is a counter here, but anything can appear here, including this one here, which is called the data latch register. So know all 4 of these for the final exam. The data latch register only does parallel in, parallel out data transfers. So here I have 4 flip-flops controlled by a clock, and here comes some parallel input data loading here. When I hit the clock, then it becomes presented on the output or your parallel output. This one's built from an array of D flip-flops, and basically that's it. A shift register, on the other hand, instead of working with parallel data, works with serial data. All right. So in this particular case, we designate an input called serial in, so that's where the data comes in, and every time there's a clock pulse, it moves over here to the next position. It takes about 4 clock pulses to move 1, 2, 3, 4 to get out here. And by the way, it needs flip-flops here. If you put data latch registers here, D data latch, this would not work because it's every time there's a clock pulse, the data would come in and then go all the way through all 4 registers because they're not edge sensitive to the clock. Okay, so that's the reason that we're using flip-flops. That's the primary reason. I can also build this with JK flip-flops. So let's take a look at that. Here I'm illustrating the same operation, moving in every time there's a clock pulse. I move 1 position across until I pop out. And I'm also illustrating a hybrid operation, serial in, and if I can have access to the 4 queues here, I will get the data in parallel. And in fact, this is how the internet works. You connect up wirelessly to your internet, it brings in data and serially fills up a 32-bit or 64-bit register, and then it collects it all at once here as parallel out, and that is then consumed by your computer. So this is a very common operation done all the time. So let's take a look at a couple examples of this, and for that purpose we're going to switch over to the artboard. So on quiz number 10, I have a couple shift registers. They can either be D or JK, it doesn't really matter. Just as more illustration purposes here. So let's take a look to see how this one works. I've got a very simple example here. Problem number 2, I've got 4 bits. I'm going to bring in 6 bits here. So the first one comes in over here, and the clock is applied to all 4 flip-flops. So therefore, all the rest of the data moves across. So I've already got it drawn out over here. Now let's apply the second bit, the second clock pulse. Second clock pulse is going to bring in a 0. All right, so let's put the 0 in over here. And then that 1 will shift over here, and then these zeros over here will move across correspondingly like this. And then the last one will pop out, all right, like that. Well, you can see, if I continue this, what's going to be the final answer? Can you see it? It's just going to be the last 4 bits here that I'm showing, okay? So these last 4 bits will appear here. And this is too simple of a question. So let's look at question number 7 now, which is more like what I'll probably ask on the exam, where initially I'm going to have registered with some data, and then I'm only going to put in 2 bits of data. Okay, so let's see what happens. I put in my first clock pulse, that 0 goes in, all the ones shift across, including this 0, and that is what happens here. This arrow doesn't exist at this point in time. And then let's go ahead and put in another piece of data here. This will be a 1, so we're going to put that 1 in here. And then that 0 will shift over here. These 2 1s will apply over here, and now that 0 is then lost. Okay? All right, so that's the answer. So let's go ahead, just 2 bits. That would be the final answer here. All right, so let's have you guys try one and see what your skill level is like. And so in this example, I hope I don't have the answer in. That's good. I've got this as my initial, just basically compare it with this example over here. I've got some data over here. I'm going to apply 3 bits. Can you tell me what the answer is? We'll shut off the video for a second here and take a look at it. Okay, so did you figure it out? Obviously, the last 3 bits here have to be the last 3 bits remaining over here, right? So just like the last 2 bits here were the same as those 2, all right? So what's remaining then? This blue 1 here would be the last one that popped down here, just like in this case, it was the last 2 1s here that appeared over here. Now, if you don't quite understand what I just did here, just go ahead and do it step by step, just like this, and see how this works, okay? And see here how this will go through here. Did I lose something here? Let me just fill this in case I had it and then it's lost. I think I had this here. So let me just fill this in here, all right? And I don't know what happened to that. Oh, I guess I moved that data down here. That's what happened. So let's go back to the artboard and see what else we can go across to. Well, on that quiz, I said question 1, we'll return to that on the next video because I've got some other examples here. We've done questions 2 and 7, I think it is. And now let's finish things off today with question number 3, the hardest problem on this quiz. All right, so what I'm going to have here is going to have 2 flip-flops. And the data is going to go from the left to the right, although on these examples that I just got done doing here, they were going from the right to the left, so don't let that bother you. So let's take a look at what I've got. So here it is. Here's my example. And these flip-flops are negative edge triggered here, so that's going to be a little bit different, but the answers would be the same whether they're negative edge or positive edge triggered flip-flops. So let's take a look at the problem. The problem says, given an initial value of Q1 and Q2, which is 0 and 1, tell me what the final value of Q1 and Q2 is when the inputs are configured to be 1, 1 for the first flip-flop and initially 0 and 1 here for the second flip-flop. Well, let's see if we can figure this out. I know from my JK flip-flop truth table that T stands for toggle. So let's go ahead and work this out for flip-flop number 1. Toggle means on the first edge of the falling edge of the clock. Notice I've got a green line here, green line here. Now for the 5 p.m. period, So a toggle here is going to be the first time that we see it, but it continues to be a toggle. So I know that in the next clock pulse it will also be a toggle. On Q2, it's initially 0, 1, which is going to be a reset. So I know that Q2 is going to get reset. And now here, I don't know what's going to happen yet because it looks like these things change. So let's explain how this works. So let's start off here with Q1, figure out the data here. So the Q1 is going to be, say, initially 0, and then it's going to be toggled to be a 1, and then it's going to be toggled to be, and then finally a 0. So my data is going to be, the answer to this one is going to be that I go up high here, and I go back down low here, okay? Now, let's go figure out Q2. Q2 is going to reset. So if it's going to reset, let's grab a little bit of blue here. Know that it's going to fall down here. All right, so therefore, I'm going to have a 0 here in this point. Okay? Now, to figure out what's going on here, I've got to look to see what Q1 is doing. Q1 has changed. All right, it went from a 0. Let me draw this in here. A 0 to a 1. Well, that 0 to a 1 this is what I'm showing up here, okay? 0 to 1, 0 to a 1. And correspondingly, the not Q changes from a 1 to a 0. So therefore, this isn't too hard, but it is a hard question, especially if you're not listening to this tape at all, this video recording. So what's going to happen here is that in between here, I'm going to change my operation from a reset to a set. Okay, so here's my answer here on this operation. This question mark is going to be a set. I didn't know what it was going to do. Now I do. It's going to be a set. So therefore, now to finish this problem, I'm going to go high and then finally come up with my final answer. So my final answer, here's the answer to the question, is that Q1 is a 0 and Q2 is equal to not Q1, Q2 is equal to a 1. All right, so now it's time for you guys to try one. And so what I'm going to do here is try something pretty simple. In an iClicker quiz situation, I would have asked for, give me all 4 of these values here. So here's the 4 values. We're not doing an iClicker because we're doing everything online. But we'll go ahead and see if you can figure out these 4 values here as we go across. All right, so let's take a look at this problem. This problem here is a little bit different in the fact that the Q is going down to the K and the not Q is going up to the J. All right, compare that with this circuit here. They just went straight across. So we did a little trick here. We crisscrossed these inputs. So therefore, when I started off this problem here in the beginning, all right, this was a reset, right? Now, if I'm going to crisscross it, this will be a set. And then after the next clock pulse, then what will happen is that this one will move over here and then become a reset, all right? Just like this one came over here and became a set. So therefore, I kind of know what my answer is going to be. It's going to be similar to this one. It's going to be toggle, toggle on the top, and then it's going to be set and reset on the bottom. Okay, so working these values out, let's see if they can figure this out. So this is initially a 0 here, so I'm toggling up here, then I'm toggling down. So my final value here is going to be a 0. This will be a 1. This will be a 0. That's the same answer as this. So this will be the answer for Q1. And the second one will be a set operation. So if I grab my set here. Now, here's something that students ask me. I'm already set. So what happens if I set a set? Well, the answer is 1 plus 1 is equal to 1. So if you're set, which is a 1, and you get set again, it still stays a set. So it just continues to go across here. Now I get a reset here, so the final value here will be 0. And so this will be Q2. Now I didn't shut off the tape here, shut up the video here, but I wanted to finish this off real fast. So this final answer here is going to be 1010. Here's the final answer. So I want to go ahead and wrap this up. So this is the conclusion. I've covered 3 problems from quiz number 10. And so the next time we meet, we're going to hit the counter and we're going to cover the rest of the questions. So stay tuned. In a couple more days, we'll have that one out. And have a good experience in the lab this week, and we'll talk to you later.